Hello and welcome everyone. This is Benham from Banks and Markets, and today in this video I want to talk about the price of the bond, basically how we can find the price of a bond. Suppose you are in a situation like this where the bond price is not given but other information relevant to that bond such as the coupon, the maturity, the yield, they are given. So I've set out an example here and I am just creating this hypothetical example in which I'm saying these are the information available, find out the price of the bond. So I'm going to make use of different methods today, and starting with this one because this is the simplest method one can think of when it comes to computation of the price of the bond. So let us begin. So what we need according to this formula is we need the coupon, we need the yield or the rate, we also then would need the maturity value, or also known as the face value or par value of that coupon, and the time period. So here the question is already giving you the time period is 25 years, and the question is also telling you the coupon payment frequency will be twice every year, which then basically means the coupon payment is semi-annual. Even if the question doesn't say anything regarding the coupon payment frequency, normally it is a standard that you will be assuming coupon payment frequency is twice every year. So with that, you know the fact that the number of periods the coupon will be paid is not 25 years but 50 different periods, because the coupon is paid semi-annual, so 50 times the coupon will be paid. So what will be the coupon that will be paid? It is not 100 times 9%, which is $9. It is not that, but half of this, because coupon payment frequency is semi-annual, so $4.5 half yearly is what you will receive. And similarly, the yield therefore is again not 6% but half of that, which is 3%. So you now have the information that is required by this formula, so you can go ahead and compute the price of the bond. So you see here what I have done, I've already written all these 50 period. So this is what you need to do, and over here you can now keep the cash flows, which here is the coupon payment. You may like to lock it by pressing F4 or function and F4, so that when you copy it down it is going to be the same 4.5 each time all the way to your 50 periods. So that's what you have. You may have noticed that I have 50 repeated here, and this will be the case if you want to put the maturity value, which is the face value of the bond, separately. But instead, if you want to keep the 100, which is the face value, over here, then you just need to add 100, and that's how you will get it. It doesn't make a difference, you'll get the same answer no matter how you organize the cash flows in your Microsoft Excel. So now we've got all this. So the last thing that needs to be done is just to find out the present value of these cash flows, which includes the coupon, and in the end the face value, which is 100. So equal this divided by, as shown by the formula here, 1 plus r power t. Therefore 1 plus r is 3%. Power t, when it says you take this one here, so that's what you can do, power period. Okay, now remember the yield is going to be this 3% all the time, so do not forget to lock it. And now just double click, you got everything that you needed, including the present value of this last payment, which is the maturity value of 100. So therefore the $100 that you will receive after 25 years today is only equivalent to $22.81. So that's what it says. But then now in terms of price of the bond, you just need to add them all up, because that's what it says by the symbol summation. So alt equal, or you can simply say equal sum, and then highlight all of these, so you get the price of the bond, which is 138.595, or you can simply say 138.6. okay, so we applied the first method, we found the answer. Now it is very common to make use of the present value annuity factor method, which is this. Now if you see this formula and this formula here, exactly same. What it does in the case of this second method is the coupons are discounted using this present value annuity factor. So we don't need to waste more time. We can simply go here. Coupon is 4.5 times, then we need 1 minus, and then 1 plus. That's in the formula. Rate, which is 3%. Remember now, power is a negative t, so minus this t is basically that 50 period, close bracket again. You completed that. Now you just need to divide it by r, which is again the same 3%. So basically you have now found this part. Okay, so the remainder is the maturity value that you need to discount, which is 100 divided by 1 plus rate 3 power, then you know it is 50, so you get that. So now again, as implied by summation sign, you need to add them together. So that's what I'm going to do. Summation of these two, and you get the same answer, which is 138.6. Now you may found this bit time consuming what we have done, but if you make use of the Microsoft Excel given function PV, this is really quick. So I've outlined the third method here, for which you need equal present value and all this. So I'm going to explain what do they mean. Equal PV is present value, open bracket. When it says rate, it basically means yield, so that's 3%. And when it says NPER, that means the number of payments, so that's 50 of them. And when it says payment, it is related to the cash flows, i.e. the coupon. Okay, and then this is optional, i.e. you don't need to write it if you don't have the maturity payment. But in this case, we know that the final cash flow is going to be this 100. So when that's available, you need to mention that, and type you can just ignore, and that is again going to give you the same 138. But remember, what you need to do is just put a minus sign there and you get exactly the same, which is 138.6 again. Okay, so that was easy and quick as well, but I also have a last method to show you, which requires the use of the function equal to price. So that's here, equal to price, and that's something I'm going to color now, so you can see I need to make use of this. Now just to save the time, I've already organized some details here, okay, and which is exactly these items here, as you can see. So I just need to put the details as given to me by this example. So that's what I'm going to do, i.e. I'm going to fill in this information required by this equal to price function. So coupon rate is therefore going to be this 9%. Now remember, in the case of this approach, you don't divide by 2, okay? So Excel does everything. So when it says yield, you just take 6%, equal 6%. Par value is then 100, that's what you take. Frequency is 2. So because that you are mentioning the frequency, it will take care. So the Excel will divide it by 2. The yield, Excel will divide the coupon rate and also find the coupon itself, so don't worry. So when it says day count, basically you can simply put 1. That's just the convention of day count. Now you just start finding out the price. So equal price, open bracket, the settlement date, which is basically the date when you exchange the bond and pay the price, comma, the maturity date, comma, coupon, comma, yield, comma, par value, comma, frequency, and then comma, you got the day count, which is here. So close bracket, and you get the same 138.59. I think I was saying 138.6. So that's what I have done. Now, here, remember the way I organize the date. I have required the Excel to report me 25 years. If you want to verify this, you can simply say year frac, and then it will give you 25 years. Okay, 25. So the difference between 2046 and 2021 is actually 25 years. So that's how you have been able to make use of the MS Excel function price in order to obtain the price of the bond. And the last thing that I want to do in this video is basically show you what does it mean when we say the bonds is selling at premium, at par, and at discount. So in order to make use of that, what I would say is we need to organize the price of the bonds for different maturities. So that's what I'm going to do. So this is 9th of March 2021, and I'm taking it all the way to 25 years. That's the maturity of the bond, and here I will change the date in such a way that at the end of the 25 years I get exactly the date which is March 2021. So if I'm reducing it, let's say by a year each time, and then if I take it all the way to 25 years, I should get March 2021. So that's what I'm doing. So you can see here, it has gone down to 2045. Now when I press here, 2044, 43, and so on, so that when I'm here at the end, it should be 2021. Okay, so that's working. So this is fine. Now you simply don't need to do anything. You just copy it across and paste it, and the Excel is basically finding the price of the bond automatically. Remember here what I needed to do. I needed to lock this, which I forgot, therefore it didn't work. So now I'm going to lock it, and that therefore in fact what I will do, I'll just type in, because it's a lot more easy to type than take those formulas and copy them. Okay, so that now I'm simply going to copy all of these, and now it is working. Okay, so we found this. Remember here what is happening. Coupon, in this case, coupon is greater than the yield. So you can already figure out that when the coupon is greater than the yield, the bond should be selling at premium. Okay, premium. But that's something we want to see with the help of a diagram. So therefore, in order to complete that, I'm just going to copy it, paste it here. It won't take long, just 1 more minute, and again paste here. And this time, when I have same, see the coupon is 9%, yield is 6%. Here I'm going to make it 9% and again 9%. So they're both 9% each, and I'm going to copy it across. And you see, you are getting $100 each time. Basically, you know this, that when the coupon and yield, they are the same, the price of the bond will be equal to the par value, isn't it? And in this case, the last one here, I'll change it to 6%, and this one 9%. So it's just the reverse of what I've done here. Okay, so basically here I'm going to paste it again, and I'm going to say coupon is now less than the yield, therefore by definition it should be selling at discount, isn't it? Now here coupon and the yield are the same, so therefore what we see is bond is selling at par. Okay, and just to illustrate this, I'm going to draw the diagram for all these prices of the bond, and you can see that this makes sense. So Here's the diagram. Let me see what went wrong. Maybe I need to check here what I did. 9 and 6, 6 and 9. Oh, I changed it, but I didn't copy it across. So what I need to do is copy it across. Now see the diagram again. That's for bond selling at discount. This is at par, and this one is at premium. So now this is the diagram, and you may have seen in various textbooks bond selling at par, premium, and discount. So just in case, if you want to write that in the name, then you can say premium, premium, and this one is at par, and the final one here is at discount, isn't it? So discount. And this is the diagram which is illustrating you the same thing here. If you wanted, you can change the time period. So that's what I'm going to do. Add it. The time period is therefore going to be these. So now I also have the date in my diagram. Where's the diagram gone? So it is here, and that's what we can see. Okay, now remember, we made this. Now this is appearing, because that I put the date, now this is appearing from this side. Before, you may remember, it was coming from this side. Yeah, doesn't matter, doesn't make a difference. What we need to, however, appreciate is the fact that the bonds, they can be selling at premium, they can be selling at par, they can be selling at discount, but upon maturity they all will be selling at par, i.e. when bond reaches that time to maturity, which is 25 years, in the case of this example, it will be equal to the price of the bond, i.e. the face value of the bond, also known as the maturity or the par value. Okay, so thank you very much for your time, and thank you very much listening.